So a catapult is used to fire a stone of mass 50 grams up vertically to a height of 4.05 meters. So we are to calculate the potential energy gained by the stone, and then also move on to solve the speed of the stone as it leaves the catapult. So first of all, let's write out the parameters that have been given in the question. So what do we have? We have the mass of the stone. The mass of the stone has been given to us to be 50 grams. But we need to convert these 50 grams into kilograms. And that will give us 0.05 kilograms. So that should give us 0.05 kilograms. We have also been given the height of 4.05 meters. So 4.05 meters. Then we have gravity to be 10 meters per second square. Now, our first part of the question is to solve for the potential energy of the stone. And potential energy of the stone, the formula for potential energy is mass times gravity times height. So mass of the object times the gravity acting on the object times the height at which the object got to, or the object is. So the mass of the object is 0.05 kilograms times acceleration due to gravity, which is 10 meters per second square, times the height. The height is 4.05 meters. So keying this into our calculator gives us 2.025 joules. So 0.05 times 10 times 4.05 is 2.025 joules. So that caters for the first part of our question, which is the potential energy. Now we have to find the speed of the stone as it leaves the catapult. So we should take note of this. Although we've just calculated for the potential energy, we might be thinking we do not have enough information to solve for the speed, but that's not true. If we know the value for the kinetic energy, we should be able to find the speed, because we know kinetic energy is equal to 1/2 times mass times velocity squared. That is what we know for the kinetic energy. So if we knew the answer for the kinetic energy, we already have the mass. So that will help us to find the speed of the stone as it leaves the catapult. But the good news is we know the value for the kinetic energy simply from the application of conservation of energy. You see, right before the stone leaves the catapult, the entire potential energy of the stone, which we've just calculated, is converted to kinetic energy. That is one interesting fact. Just before the stone leaves the catapult, the potential energy, which is 2.025 joules, is converted to kinetic energy. The whole thing is converted to kinetic energy. That means as the stone leaves the catapult, the kinetic energy is also 2.025 joules. So that means we can just put 0.025 joules should be equal to half times the mass. The mass is 0.05 kilograms. So 0.05 kilograms times V squared. So that caters it for us. So we'll just multiply through by 2 and divide by 0.25. And that should give us the value for V squared. So we have 2 times 2.025 divided by 0.05 should be equal to V squared. So in order to find for the value for V, what we'll do is to find the square root of both sides. So the square root for this value, you can punch it in your calculator. So the square root of 2 times 2.025 divided by 0.05 will give us 9 meters per second. So that gives us the value for the velocity of the object as it leaves, so that gives us the speed of the stone as it leaves the catapult.